So the idea with iterators is to generalize the idea of going through something, right? Probably written a few for loops and see at this point that say, like, for I equals 0, I less than the length, right? Plus plus I, access my array at I. Or if you've written in Python, you've probably had the much nicer experience of saying like for element in thing, right? Do something. That's a concept of an iterator. This doesn't always work because not all containers are linear, right? Or indexed by some value that you know. For example, maps have some key, but you don't have any idea what the keys are, right? And you need to be able to go through the values. Or again, like in Python, you need to be able to go through the dictionaries, but you don't know what the keys are to be able to access them by some index. So iterators allow you to generalize this concept, and they're pretty easy to make, and they just involve writing a lot of boilerplate code. What they are is generally they're a class that holds some reference to the class that they're iterating over, and some information to keep track of where they're at in that thing. Also, it's quite common for your iterators to be friends to be able to access your private parts, but they don't always need to be able to do that. Then these iterators will tend to define a few overloaded operators. Star to access the member. Arrow can also sometimes be used to access the member. Plus plus, minus minus to be able to go forward or backwards. Equals equals to check to see if two iterators are the same, and not equals. Not all of these are again defined. Some iterators won't define minus minus. There will only be forward iterators. You can only go forward through the thing. For example, an iterator over a file might be a good example of where you can only go forward. Once you've read the thing, it's been read, and it's really hard to go back. Sometimes things are bidirectional iterators. You can go forward or backwards, but only by 1 unit, whatever that would happen to be. For example, a good example of like something that would only support a binary or a binary iterator to go forward and backwards would be like a doubly linked list, where you have a pointer to the next thing and a pointer to the previous thing, but you only know how to get to that next object. Or again, a forward iterator might be defined over a singly linked list, right? Once you go forward, there's no way of getting back, right? With a doubly linked list, you also have ways of going backwards, so you'd probably implement minus minus as well. There's another class of iterators called like random access iterators that allow you to access any random thing inside of it. And they tend to support like the plus operations as well. I want you to move me forward 5 things. I want you to move me back 2 things, right? You probably have random access iterators supported on like vectors, right? Because you can access any of the elements inside them. The container class also has methods to get an iterator. Those were some of the methods that you saw previously, like the begin and end. Give me an iterator to the beginning of over the objects that I'm containing. End, give me an iterator to the end. And in general, the end iterator that you get, it's one past the end, right? So you shouldn't ever dereference something that's at the end, because then you've gone too far. Does that make sense? Do you guys have any questions about iterators so far? Okay, then let's write an iterator. That's really all you need to know to be able to write iterators, but a good example helps. So you guys have probably all used the range class before, right? Inside of Python. You guys use range, right? You guys remember, what does range do? It kind of gives you like well, it represents like a sequence of values between some start and end, counting by some step, right? Right. I want my range from 5 to 13, counting by 3, right? And you represent that sequence of values. And a lot of times you iterate over this range, like for I in range, whatever, and you go through those values. So there's 2 parts here. One's the iterator over the values. And the other thing is the range itself. So as our first example, we'll implement a range object, and then we'll provide some iterators over it. Then if we have time, we'll also provide an iterator over our string class that we did the other day. And we want the dot idea slash c dash build dash bug. Now, still like getting things started. Also, why can't I add? Okay. Okay, well, we'll just do this the old-fashioned way. Okay, we'll try closing this down and see if that works. Okay, while we wait, you have any questions? So first one would be like, to represent a range object, what information would the range object need to contain? Right, so you're trying to represent some values between some start to some stop, counting by some step. So what information do you think you would need inside your range class? I want you. Not a trick question. You need a start, step, and an end, right? So start, stop, and end. This finishes doing its job. Or you can do it, computer. I have no idea why it's taking so long. Okay. So over here, we have our range. And we might define this slightly different. So over here, oh, not sure anymore. So a lot of times when you have ranges, right, there's one that just gets called with, maybe we have start, stop, and step, right? We have a version that gets called with range int stop, right? And then we also have another version that gets called with range int start, int stop, right? So we're able to construct our range object 3 different ways. So for this first one, oh, that's not where you go. Range.cpp. Right, so this constructor should be really easy, right? Start gets initialized to start. Stop gets initialized to stop. And step gets initialized to step. That one's easy. We call it range start, range stop, range step. Stop and range. No, other way around. Okay. Then over here, right, we can be kind of lazy and just reuse that first constructor over again. So we can call this with a range, and our start should be equal to our start, and our stop should be equal to our stop, and our step should be equal to 1. And then finally we can do it with the last one for stop. Right, we can reuse the first one, or even reuse the second one, right? Range, and our start should be 0, and our stop should be whatever they said. Great. So we're just reusing the constructors again by calling them to do our initialization work. So now we have our range iterator over here. And so when you're working with a range iterator, there's a lot of blah that goes on in here to get things done. So we have to have some initialization, and generally when you're initializing, you need to have something that you're going to be going over. So here we have a reference to our range that we're going to be iterating over. Right? We also need to keep track of what position are we at inside the range. Does that make sense? So our constructors are over here are just going to do the initialization work, right? This gives you the ability to start the position at some value, and this gives you the ability to copy one. So we're going to skip over doing the constructors, but we will talk about the other operators. So the first operator we're going to implement is the star operator, right? This is supposed to get you the value at the position that you're at. So what do you think this guy should return? Just pause, right? Pause is keeping track of what the value that we're at is. So we can just return pause. The next thing that we want to be able to do is operator plus plus. And again, remember that we have back here made, remember back here we said that range iterator is our friend, so he has full access to all of our members. So how would you go to the next thing? Yeah, right, pause plus equals, and then we have to have our range dot step. And again, because we're, oops. So we go to the next thing, and then we return an instance to ourselves, right? We're able to do this again because we are the range's friend. So now here, this shouldn't be operator plus plus, should return a const. So now we want to do operator plus plus, right? Well, this is the plus plus, that's the the post increment. So how should we go about doing this? Well, the easy way is we just make a copy of ourselves, right, to keep the old value, and then we can return that copy, right? So I make a range iterator called copy, and I want to be a copy of me. So how do I say I want to be a copy of me? Star this, right? And then down here we can eventually return the copy. And now, again, I still need to advance myself. So what should I do? Right? We can be lazy and just do plus plus star this. Right? And this guy is calling this operator over here. Or again, if this looks a little bit like weird, we can also do, depending on which one you like more, you can just say operator plus plus is the alternative way of doing it, but use whichever one you like more. Any questions so far? So again, this one should be a const. So operator minus minus, what should we do? Right, so we should do like pause minus equals the step, or the range dot range step. Right, go backwards. And then again, you're going to see that like a lot of this code is just like boilerplate code. It's very fun code to write because we just do the same thing over and over again with small modifications. And most of your like the code you're writing for iterators is going to be like blah code. So we'll skip over some of these or values over here, and we'll go to some more of the more interesting ones. So the first thing that we want to do is operator equals equals. So we want to check to see if two iterators are the same. So for them to be the same, what would they have to be? What would have to be true for these iterators to be the same? They have to reference the same object, and they have to reference the same position. So the first part of referencing the same object, right, is you have to do the address of range equal to the right hand side dot range address, and does my pause equal the right hand side dot pause? Right? Does that make sense? For getting not equals, what could we do? Well, they're not equal. right? So you call the equals function so you don't have to keep rewriting the same thing. And if we make mistakes back here, we're always free to change. And for someone to be less than, again, you'd still have to be over the same object, and your position would have to be less than the other person's position, right? It's not going to be like too complicated. So again, we're probably going to keep reusing this portion of code, so we're probably going to want to make this into its own method. So down here, I might want to put something under private, like private bool, you know, over same range. Const here, const range iterator reference. We call this one, you know, other. And then we can just steal this and put it over here. And now we can just say, are they over the same range? I call this other now. And then this one we can say they have to be over the same range. And my pause has to be less than your pause, right? And we can keep going over those and doing them like this. The other thing that we might want to define is here we have operator bool, and we also have operator not. So operator bool, let's see. Define this one first. So a lot of times you might want to check to see like if the iterator is valid before you use it. So like if iterator, right, then star iterator acts as values, right? So how will we know that if we're going to be valid? Right? How are we going to be at a valid position in this range? That sometimes that works, but it doesn't work if you have like a negative step. Right? Because if your step is negative and you're trying to like advance like in a negative manner, it doesn't quite work out so well. But close, right? For positive ones, it would work. But like in general, you have to be in between start and step, right? And do we have to do, would that still hold true? Like, it doesn't work if we're doing like negative steps, right? So we might have to have some condition on the step. So, right, if, or we could just do like absolute. So we could just Google like C++. Oh yeah. Looks like it's in multiple. See stdlib, I guess, is the one that we want to include. And then down here, we might say return the absolute value of range dot range start. or say the absolute value of pos is greater than or equal to range start, and the absolute value of pos is less than absolute value of range dot range stop. You have a question? Does that make sense? So it has to do with like negative numbers. So let's say your start is equal to, say, 10, and your stop is equal to -3, and your step is equal to -1. And you're currently at 5. Right? That is in this range because we're doing the negative iteration. Right? But if I just check to see if 5 is greater than the start, no, I fail. So oh, I guess we're still screwed, aren't we? I guess we have to do it the hard way then. Good catch. I was trying to be fancy and didn't work. So if step is less than 0, do something else. This one we can return range pos is greater than or equal to start range.start, and pos is less than range.range stop. And so if we're negative, what do we have to do? Right, so return range has, pos has to be less than or equal to range.range start, and pos has to be greater than range.range stop. Seems good. And then over here, right, if we want to negate ourselves, wow, pretty easy. Return not static cast to a bool. Like this. So I cast myself to a bool using the operator bool function that we just used, then I return the opposite of that. So if I want to know if I'm not good. Does that make sense? Are there any questions here? Okay. Then finally, you didn't implement every single piece that's in here, but a lot of times, right, with the iterators, you want to be able to do that for syntax, like, for value in this thing, right? Do that. So what you can do is if your class just defines 2 members, they are begin and end, and those functions return iterator-like objects, you can then call your class with that method, right? You can say like for value in thing, do thing. So over here, we have the begin and we have the end. So here I need to get a range iterator, right? And it should be over who? If I'm trying to get a range iterator, I want to get a range iterator over myself. So start this. And then what else is range iterator dot want? Range iterator wanted Well, I guess the position that we should start at would be start. But this guy over here, range iterator, already does that, already initializes it at our start. So we're good over here. So now we have a begin function. It returns our iterator. And then we need an end. And again, when you're generating an end, right, this guy needs to be past the end. So he should be equal to what? Well, yeah, but what's the end? Well, stop is not a good value for the thing to be at either, right? If your iterator is at stop, you've already gone past the end of the range, right? If you have a range between 0 and 10, you go between 0 and 9, right? So 10 would be beyond. So we just put in the stop. Does that make sense? And now we should be able to iterate over our values, assuming we actually implemented enough of this class over here. And it might complain about some of these, so I'm going to comment them out. Or actually, here, slash here. And then if we pop back to main, right, so we have a range 1 and a range 2. We equals the begin, and then we see out the value. And then we also go auto val, blah, blah, blah. And then we attempt to see out the other guy by also using his iterator. And then we can also use the auto right here, create a copy. Or we could say, that should be good. Hopefully we got enough done that actually compiles. Then we can see, oh, nope. Okay, we also probably want to define our outstream operator. So what do you think this outstream operator should print for a range if you print it out? So do you think it should print all the numbers in the range, or do you think it should just print out its start, stop, step? Probably like start, stop, step, right? And if we're lazy and we just want that, what we can do is we can have C-line make it for us. So code generate stream output operator. Then you say, what things do you want printed? I want all of them. And then, hey, it just, prints them out. And so if we go here, uh-oh, looks like we have an infinite loop somewhere, probably in the negative one, right? So now it'd be time to debug. I thought I killed you, die. So I'm assuming our problem is probably down in here. Not this one. It's this one we're going backwards. So you can see that we got everything out. And at this point, we need to figure out, well, why haven't we reached the end? So we might set another conditional breakpoint inside here. And we might say, well, I want to stop here if star our iter is greater than, or oops, what's our stop value that we said? Less than or equal to 1. Then we can resume. So apparently something's happening. And we might want to check to see. Oh, I said less than or equal to 1, right? So let's see if it gets to here, or if it's getting stuck in this loop, or if it's getting stuck in this loop. It's probably, fixing one will fix the other. Yeah, it's getting stuck in the first one. Then, so let's set a breakpoint. Again. I guess we're down here. Oh, okay. We messed up on the less than operator. Okay. So we can say, what's our iter at? So our iter got to negative something. And I think the issue here is how we defined the not equals, or the equals. Oops. So remember that we said that when we return the end, right, it returned the very last value. But notice our step size is by 2, so we skip over that value. Right, back here we said that, stop this. Where'd you go, Ming? Right here, right, we said that we wanted to start at 10 and end at 1, but if we go by negative 2s, right, we go 10, 8, 6, 4, 2, 0. So we don't stop at 1. So we're doing our comparison between like end iterators incorrectly. So what we might want to do now is back in here is say if right, so if they're both good, right, we should be able to, they're both like in the range, they should be fine, right? Otherwise, if not RHS is good and not this is good, for whatever reason, right? If they're both bad, just return over the same range. Right, they have to be over the same range. Otherwise, right, return false. That would mean just one of them is good. Does that seem valid? I just have to go check our operator equals equals to see it makes sense. Oh, this is operator equals equals. Yeah. Why are doing this? Did I put that in that minus minus operator? Oh. This would be, we have to check our operator pool. I think that might fix things. Maybe. Fingers crossed. Well, hey, that did it. Do you guys have questions on that fix? Because that was kind of complicated. Right? Because if one of them's out of bounds, I don't care how far out of bounds it is. Right? And that's what it needs to be able to match with the end. We'd also probably need to go and fix our operator less than, because if you have like a negative step, would you always still want to be using positive values? Right? If I was inside this range and I had the value 5 and I had the value 6, which one is really less than? Is 5 less than 6? Or is 6 less than 5? Is 5 less than 6 because numerically 5 is less than 6? Or is 6 less than 5 because it comes earlier in the range? Does that question make sense? Right? Right now we've currently defined as 5 being less than 6 because numerically it is. Right? But you might want to do the other definition potentially where 6 is less than 5 because it's earlier in the range. And for iterators, probably the second definition makes a little bit more sense. If you guys still have questions, I'll be around for a little bit after class.